Okay. I hope this is easy. You can do this the whole long way we've been doing, but we know a formula for the slope of x squared. It's 2x. So the slope of x squared at 4 is just 8. Okay? We know that formula. We can use it. Okay? And since the slope of it is 8, the tangent line, which we discussed, is just a line that goes through the same point. So we have a parabola. That's what x squared looks like at 4, 16, which we'll say that's that right there. If we were to graph the tangent line, it would go through that point and have a slope of 8. So to go through that point and have a slope of 8, we do y minus the y value equals the slope x minus the x value. Sound good? And in terms of if that's our final answer, okay, you can leave it like that. You can put it in slope-intercept if you feel the need to. I don't care. Okay? Open-ended wise, as long as it's equivalent to what it's supposed to be, you're usually pretty good with however you want to leave it. Okay? Certain things I'll tell you that I want simplified, but that's fine. Everybody good? Okay. We're going to talk a little bit about some stuff today. I'm going to go over the homework and everything in a minute. All right? But let me go through these notes here. And then I'll put this online in case anybody was absent or not paying attention or feeling sick, whatever. But we just talked about this. We found the slope, it wasn't yesterday, a couple days ago. We found the slope of x squared a whole bunch of times, and it looked like the formula for it was 2x, right? Okay. Now that was all like anecdotal. We just found the slope several times, and it happened to be double it every single time. That's not really like a mathematical proof. Okay. It is 2x. It happens to be true. But just doing that a couple times isn't really showing that. Okay. So a couple of vocabulary things. That new function is called the derivative of f of x. Lots of functions have derivatives. Okay? Not all functions have derivatives, which is weird. It's got to be like a crazy, weird function not to have a derivative. Okay? We'll talk about that. And it's denoted like this. You call it f prime of x. Okay? It's just a little apostrophe right there. That's called f prime of x is how you read that. Or the derivative of f is the same thing. Okay? And in general, you can write this down. If there was a function h of x, no matter what it happened to be, h prime of x tells you the slope of that function. That's all that means. Okay? That's notation for that. So, where are we at here? We can think of it as, so the derivative is a fancy word in your head for right now. You can think of it as the slope function. And again, it just spits out the slope of the function we started with. Okay? They're related to each other. So, we're going to learn in a little bit how to find the derivative of pretty much any function. And we'll be able to attack them and find the derivatives. Okay? And we're going to learn a lot of shortcuts. But right now, I'm going to show you one little, like, kind of a longer way we can do it with limits. So, what we did with x squared, like, this is us proving that the slope is 2x, okay? Was I picked an arbitrary point, 1, 1, and then we picked a variable point, right? A squared. And we found the slope between them and then brought them close together. But when we did that on x squared, the fact that I picked a static point, 1, 1, and a variable point, a squared, when I find the slope between them and bring them together, now I'm finding the slope at 1. I'm not finding a slope anywhere else, just 1. Okay? But if I were, instead of to pick that point and just call it x comma x squared, even though I'm drawing them right there in that picture where they are, those 2 points could be anywhere on that curve, depending on what a or x is. Okay? If I find the slope between them and bring them infinitely close, now what I have left over won't be the slope at one point. It'll be the slope at whatever x I want it to be. Okay? It'll actually find a function that tells me the slope anywhere instead of finding the slope at just one point. Okay? And we're just going to use the slope formula. So, it doesn't really matter which direction you subtract as long as you do it the same way for the y's and the x's. Right? That's the slope between those 2 points. Okay? Okay. And we know that x squared minus a squared factors like that, which means the slope between those 2 points will reduce all the way down to x plus a. Everybody good? A little bit of algebra, not too hard, right? Same concept, just slope, reducing it down. Okay? What does x plus a tell me? If I were to plug 2 and 6 into there, I get 8, right? What does that number represent? Slope between x and 2 and 8 on x squared exclusively. So from 2, 4 to 8, 64 basically. Okay? Now, it just reduces down to that, which is nice. So that says if you want to find the slope between any 2 points on x squared, all you need to do is add their x values, which is kind of crazy. All right? But we don't really want the slope at any 2 points, right? Between 2 points. We want the slope at 1 point. So we want to see what happens when we bring those 2 points close together. Y'all can see what's going to happen here, right? But the notation for that is let's bring a infinitely close to x. What's up? I'm in the way. Okay. Excuse me. X plus a, I guess, to keep it the same. Right? I wonder what happens if we bring them. I don't know there's no numbers in here. But a and x are just numbers. We haven't chosen what they are yet. But if I bring a infinitely close to x, then it just approaches x, and my slope approaches x plus x, which is 2x. Great. Cool. And that shows that the slope at any point on x squared is just 2x. Make sense? Okay. And we can do this for almost any function. Any nice, easy function we're going to deal with is going to be able to reduce down like this, okay? So we're going to do another one. Go through the same process. If I want to find the slope of x cubed at 1, I could do what I did before. I could choose the point 1, 1, right? Because 1 cubed is 1. And a, a cubed. But rather than do that and do all that work, I'm going to skip to the back of this paper. And I'm just going to find the slope of x cubed at any x value. And once I know that, I can find the slope wherever I want. I'll just plug into it. Okay? So we're going to make a formula for it. So it's going to be way less work to find values everywhere else. Okay? Also, this is a little bit off topic, but knowing the slope function or knowing the derivative for a function, you can analyze that. You can find out where it's 0, you can find out where it's negative, you can find out where it's positive, you can find out what happens as you go to infinity, and it tells you all about the slope of this curve, which in turn tells you all about the curve and how it's moving. Now, x squared is not a super interesting curve, right? It probably goes down and goes back up. Okay? But you can see 2x will be negative if x is negative. That's why x squared is decreasing, right? If x is negative, it's decreasing. It'll be 0 when x is 0. It'll be positive when x is positive. So it tells you the curve goes down and then back up again. All right? We're going to exploit that later on. Do you remember last year if you had to graph maybe you guys did this. If I asked you to graph like x minus 3, x plus 2, x minus 1, like that's a cubic function, right? Okay. We know the end behavior of a cubic has to be down, up. We know the zeros of it have to be -2, 1, and 3. We can even go so far as to find out what the y-intercept is by plugging in 0. That's going to be 6. Is that okay? It tells me an awful lot about this curve. Well, that doesn't look great, but you know what I mean. So it goes up, comes back down again, goes back up again, okay? But something that maybe you wondered when you do this is, well, how do I tell, like, how far down do I go here? How do I tell how far up do I go? How can I tell where the max is and where the min is? You need calculus for that, okay? What's the slope at the max and the min? If you zoom in on it, it looks like what? A flat line. So the slope there should be 0. So if I can find the derivative of a curve and find out where it's 0, I know where the maxes and mins have to be. And knowing the maxes and mins is a super important thing in a lot of industries. Okay? So let's go ahead and find the slope formula for x cubed. Okay? Actually, before we even do that, you know what x cubed looks like? Comes up, does this, does that, right? I should expect my slope equation here, my derivative, to always be positive. You see that this is always moving upward, except it's 0 right at the origin. So I'm expecting my derivative to be always positive, except for it's 0, it should be 0. Make sense? Without doing any work at all, that's just something I can see is going to happen. Okay? But to find the slope between them, we're going to take our 2 points, which we're not going to pick a number for. I use x and a. You can use any letters you want. I like to use x because your derivative will usually have x in it. Okay? And we find the slope between them. That's going to be, my pen wants to work, x cubed minus a cubed over x minus a. And if I simplify that down, it would be a formula for the slope between any 2 points on this curve. I don't want that. I want to know what happens when I bring the points infinitely close together so that I have a formula for the slope at 1 point. Okay? And what was true before is still true. If I plug x into this thing, I'm going to get 0 over 0. Cool? Which means something's got to cancel. Specifically, x minus a or a minus x. One of those has to cancel out. Okay? I don't know if you all remember how to factor a difference of 2 cubes. All right, but it is x minus a. That's how this factors. Okay, this is a formula you can look up. And over here you have the first thing squared, x squared, plus both of them multiplied together, plus the last thing squared. That's how x cubed minus a cubed factors. Okay? And that's all divided by x minus a. You can see the x minus a is just going to cancel out. And I'm going to plug. Now I can just plug in and see where it's going. I can see where it is. Plug x in. That's going to give me. So I'm plugging in x where a is what's happening. So I get x squared was already there. This term here is going to become x times x. That's just x squared. This term here is going to become x squared. So my derivative is 3x squared. Okay. Oh, and you see that's always positive, right? No matter what you plug into that, it's always a positive number. And if you plug in 0, you get 0. Cool. What's the slope of x cubed at 1?
3.
It's just 3. Yeah, put a 1 in there. It's 3. That's the answer to this question up here. Okay, so we don't have to keep doing the slope thing over and over again. It just works out. Okay, so that's basically it. Your homework is to do what we just did here. I want to go over some of the stuff you guys were doing in the last couple of days, though. All right, but there's only 3 questions here. You should at least be able, young adults, to get to this point here where you set up the slope equation, right? That's just setting it up. The algebra part of it is simplifying it after that's all done. Are there any questions from the other day? What did we do the other day? You had limits notes 3 was the first thing, right? We'll talk about a couple things on here. So I put a video online of me going through some of this stuff. I'm sure it was enthralling. Yeah. Yeah, I know sometimes I talk fast and I just get so excited about math and it's going so quickly. Okay. I know you can YouTube it like speed 0.5. Make my voice all deep, it'll be good. Okay. We walked through all of this, and we talked about all this stuff the other day about how basically there's a hole, and if you simplify it, it takes the hole away. All right. I want to get down here and make sure we understand what's going on here, okay? So that's what's up here. There's a difference between, we talked about this, where a function's going. I'm on the second page here, right? Where a function's going and where a function actually gets to, right? There's a difference between where the y value is and what it actually approaches. So I made up this little graph here. And you all know we said f of 1 was just 5. That's easy. Okay? But the limit as we approach 1 was 2. So everybody on board, come on you, with that, right? The y value is 5. That's where the point is, but the limit doesn't, or the function doesn't head towards that. Heads towards 2. Okay? Algebraically, what that would be us doing, forget that 5 for a second, but the hole that's there is us factoring and canceling something out and then plugging in again. That tells us where the hole is, basically. Okay? Notation-wise down here, kind of important. There is no point here on this thing, right? So f of 3 is just undefined. That's totally fine. Okay? But now we have, this is our first look at a graph that does something different on the left side than it does on the right side. Okay, so at any single x value, there's really 3 things you can worry about right now. Okay? There's more stuff, but right now 3 things. Where's the left side going? Where's the right side going? And where's the actual point? Okay, they're all 3 separate questions that can all have the same answer or different answers. Okay? So it makes sense that from the left, that's what that little superscript there on that 3 means. right? On the left side, that's right here. We're headed towards 3 on the left. That is headed towards a y value of 1. Everybody feels good about that. Okay? If you ever get confused about that, sometimes kids want to start, this is what kids will do. If kids get this question wrong, it's because they're doing this. They'll go, okay, 3 from the left. Here's 3, let's go left. Oh, it goes to 0. Okay? That's not good. That doesn't make any sense. You don't go 3 and then go left. You want to go 2, 3 from the left. All right? So you can think of it like this. I want to plug in values like 2.9999. That's like right here. If you go up there, where's it getting close to? 1. Make sense? That's the left side. The right side is headed towards 3. Because they are not the same thing, because the limit is not the same on both sides, then there is no limit at 3, because they're not going to the same place. And the notation for that is, yo, this limit does not exist, D&E. Okay? That's different than undefined, kids. A function is undefined if there's no point at that x value. A limit will not exist if both sides aren't going to the same place. They're different things. Okay? And to beat this to death here, let's say we had the x value 4, and this side was coming in here like that, and this side was coming in here like that, and there was a point up here. We already saw this. Let's say that was 5, and this is 3. The limit as we approach 4 is 3, right? Everybody okay with that? But the y value at 4 is 5. It's different. Okay. Let's take this away for a second. Let's see. This. Does it make sense, again, that the limit as we approach 4 from the left is 3, and the limit as we approach 4 from the right is 5. Ready? Even if there's a point here. The limits are still what they are. Doesn't matter where the point is. That's a separate question. Make sense? Okay? Don't average them together. Those are the limits. So because they are not the same, the limit as we approach 4, f of x, does not exist. Again, regardless of where the point is. It doesn't matter. Easy enough? Okay. From this homework down here. A couple interesting things that I think you should know. Let me see here. Any questions on this at all? In particular? Some of them were decimals that you just had to get close to. If you're like accurate to 2 places, it's fine. Okay? Like that was not the point of you to find out exactly what like value it is. Like if you could approximate it, that's fine. I want you to just see the graphs are headed places, basically. Okay? Anything you want to look at in particular? I'm going to go over 10 just to make sure you guys feel okay with this absolute value stuff. What's up, Emma? Sure. 11. Okay, let me do 10 first, then we'll talk about 11. Okay, because they're kind of similar ideas. All right. So when you see, let's just come over here. That function there is that you usually see it like this, but these are the same exact thing. Okay? And I want to go over this because I know sometimes like kids just want rules. When they see absolute value, want rules to follow or something. I want you to understand what's going on, so you don't really need a rule. You just think about how to handle it. Okay? But for the most part in a Calc 1 class, if you see absolute value, it'll be something very simple inside of it. All right? And you can just graph it. All right? So graphing this should make sense for us. All right? And when I say graph this thing here, something we can do is just plug in some x values for that. Like this is not a hard function. If I put a 3 into there, I get 1 over 1. That's 1, right? So let's say this is 1. Plug in 3, you get 1. If I plug a 6 into there, I get 4 over 4. That's a 1, right? If I plug a 2.2 into there, I'm going to get 0.2 over 0.2. That's a 1. Guess what this thing always equals up here? No matter what you plug in, you can see it's just going to be 1, right? They're always going to cancel. But if I plug in a 2, I get 0 over 0, which means not for the limit-wise, but for the function, there's no point there, right? That's what that looks like. It's just 1 all the time up to there. But if I plug in values on the other side, like 1, when I plug a 1 into that, I get 1 over negative 1. Okay? That's negative 1. When I plug a 0 into that, I get 2 over negative 2. That's negative 1. If I plug negative 6 into that, I'm going to get 8 over negative 8. That's negative 1. So everywhere down here, it equals negative 1. But at 2 again, there's no point, so it looks like that. Make sense? If you think about that graphically, which was not very difficult, I just plugged in some values. Now when I ask you what's the left-hand limit, even if you don't have a calculator, you can see the left-hand limit is -1. That's where the left side's going. The right-hand limit is +1, which means the limit as we approach 2 is DNE. So the absolute value, you're not going to treat it the same way we treat everything else. You're not going to do algebra stuff on that, right? You're going to graph it. Okay? And just to make sure we're all okay, everyone knows that the absolute value of 7 is 7. Everyone knows the absolute value of like -4 is 4. But what you're really doing there is you're multiplying by, it's 4, but you're really multiplying it by a negative to change its sign, right? So when you see absolute value, I want you to keep in mind, if you look at this function right here, it could really only do one of two things. The absolute value could leave it alone and do nothing, and then that function equals just x minus 2 over x minus 2, which is 1. Or it could change the sign of what's in the absolute value. That's a possibility. So then it would equal the opposite of x minus 2 over x minus 2, and that's just -1. So that's the only two things that thing can equal. When will the absolute value leave x minus 2 alone? When x minus 2 is? Well, when x is greater than 2. When x minus 2 is positive, right? And x minus 2 will be positive if x is above 2. That's what that says. If x is above 2, that thing just equals 1. And when is it going to change the sign? When x is less than 2, because now we have a negative value in there. So it's going to equal -1 when x is less than 2. And that's what that graph looks like. 1 when x is above 2, -1 when x is below 2. Make sense? If I couple that with my next question, number 11, we can really just think of this as x times x minus 3 over x minus 3. Okay, same thing. What can this fraction here equal? Either 1 or -1. That's all it can equal, which means our whole function will either equal x or -x, right? Because it's x times that. So it's either x times 1 or x times -1. It'll just equal 1 times x when what's inside of this absolute value is positive, right? That's when x is bigger than 3. You've seen functions like this before. It's going to equal -x. Oh yeah, when x is less than 3. We're going to spend some more time doing these. But that's what's going on. That's all that absolute value thing does, okay? It either leaves it 1 or changes its sign. So this graph looks kind of cool. Not really cool, I guess, but at 3 it jumps. On this side it equals x, and on this side it equals -x. So it's kind of weird. I have to cook up questions like that for you so that I can make weird functions that have different limits on both sides so that I can see if you know what you're doing, basically. Okay? That's the sole purpose of me making questions up like that. Do you understand left and right hand limits? I can't just give you like x squared. It's the same thing the whole time. Okay? So that's that. How about the homework from last night? We were in class together. Did I show you conjugates yesterday? Let's talk about 5 and 6. Did we talk about 5 and 6 from yesterday? Yeah, the answer key's online to this. It's f of x equals, what was it, like 1 over 2x plus 4? We talked about this one a little bit, didn't we? We talked about part B. No? Am I making that up? Okay. I didn't even go over it. Oh my, what a jerk. Okay. So we had x equals -2 and x equals 1, right? And I want you to find the slopes there. So, to find the slope at -2, I'm going to do b first because it's easier. You got to plug -2 and you need a point, right? That's how we do it. You need a point. If you put -2 into that thing, though, you get 1 divided by 0. Okay? So we're supposed to find our point. When you put -2 in, you get 1 over 0, and 1 over 0 is not a it's not a number. So that means this function does not have a point at -2. Does that make sense? And if it doesn't have a point, then you can't zoom in on it. There's no point to zoom in on. And if you can't zoom in on it, then it will never look like a line. And if it never looks like a line, it doesn't have a slope. Make sense? If it doesn't have a point there, then it can't have a slope. Cool? We actually give that a name. That's called non-differentiable. It sounds fun to say. All that means is it doesn't have a slope there. Okay? So that just no slope is all I wrote on my answer key or something like that. Cool. Find the slope at 1. We can do that one. We take the point 1 comma 6, 1 comma 1/6, which is the point we care about. And then we take the point a comma 1 over 2a plus 4. I'm going over this one because kids had questions on this from previous classes. So I figure you guys want to go over this maybe. Okay? But the setup's the same. Everybody okay with that? We have our point we care about and the made up point that can be anywhere. Cool. We're going to find the slope between them. 1 over 2a plus 4 minus, what's going on? Minus 1 over 6 over a minus 1. And I want to know what's going on as I approach 1. If I drop a 1 into there, I get 0 divided by 0, which means a minus 1 has to cancel. I just got to make it happen. I told you before, if we have complex fractions, we don't want those. We have to get rid of them. And we get rid of complex fractions by multiplying by the denominators we don't want to see. We can actually multiply by a little bit smaller than this to get our least common like multiple, but that's okay. We can just do this. Okay, so we're distributing that into here. All right, and again, just to point this out for everybody here, this is multiplication out here, right? We don't distribute into multiplication. You just multiply what's there. There's a big minus over here. So when we multiply these two things, they have to get distributed on each side of that minus sign. That's how that works. Okay, so both of these things get multiplied to here, but when that happens, the 2a plus 4s are going to cancel. There's going to be one on top and one on the bottom. So we're just left with a 6 minus. When I multiply both of these two here, the 6s are going to cancel. And the one thing kids mess up, well, most common, I would say, is they forget that there's parentheses around that thing. Okay, so if you forgot those parentheses, you would not get this to cancel. It's minus that whole quantity, so you got to put that there. And on the bottom, our whole goal was to cancel out an a minus 1. I can see the a minus 1 there already, so I'm not going to worry about that. Boom. You got that going on. It's okay. And I'm going to do a little bit of cheat. This is not good for you to do. You wouldn't do this on a test or anything, but I'm going to do this to skip some time here. That reduces to 6 minus 2a minus 4, which reduces to 2 minus 2a. Remember, our goal is to get an a minus 1 out of here. If I take a negative 2 out of there, I'll be left with negative 1 plus a, which is the same thing as a minus 1. So that whole numerator is really just negative 2 a minus 1. Okay? Well, that means that. And again, you should really rewrite that. I'm being lazy because I'm old and tired, and you guys are young and full of life. Okay, you can write it. Okay, good, thank you. The a minus 1 is going to cancel. Yes? And once you do that, you can plug, you've taken the whole out now. We can plug in 6, or 1. So you're going to get negative 2 over 6 times 6, which is 36. And that's going to be negative 1 over 8. Easy enough? That's a slope. Cool? All right, students. And let's take a look at that I'll do one of the set number 6, okay? Because we haven't really dealt with square roots, and you got a square root to look at tonight, so I want you to be able to handle that. All right? What was it? Square root. So this is 6. I think I gave you f of x was square root x plus 1. We want to find the slope at 3. Okay? So I'm hoping you can start this off. Again, we're doing the same process every time. Get a point you care about, get the variable point, get the slope between them, simplify. Okay? If you put a 3 into there, we get a y value of 2. So that's our point we care about. And then our other point, which we're not going to name, of value 4, we're going to call it a and root a plus 1. Okay? The slope between them is root a plus 1 minus 2 over a minus 3. Is it? Nope. Nope. There you go. And y'all can see if you put a 3 in there, you're going to get 0 over 0, right? Putting you guys asleep on my. We'll do some calisthenics at the end of the day here. Think about burpees. Excellent. Okay. Do you guys know how to do this? Have you seen this before? Oh, Mr. Flick is so good. Don't tell him I said that. I don't go to his head. Yeah, I don't care. He thinks too much of himself already. Yeah, so we need to get that square root out of there. And the way you do that when you have a root with a minus or a plus in the middle is you multiply by the conjugate. And the reason we're doing that is because A minus B, anything minus anything, times the same two things being added will give you the first thing squared minus the second thing squared. That's the whole point of the conjugate. That's what we like it for, okay? So that means because I want to get rid of that square root. Just like when you have a complex fraction, you want to get rid of the fractions. So we're going to multiply this by the conjugate. Now, the conjugate of this does not change the plus in that square root. That square root's like one thing. Root a plus 1. That's one thing. You don't change that. You change the sign between the two things. So the minus becomes a plus. Okay? And because I'm multiplying that in the numerator, I'm going to have to multiply in the denominator. There you go. Now, I know, right? It is my hope that you don't need to FOIL all that junk out. We're multiplying conjugates. And what conjugate's going to do is give you the first thing squared. The first thing here is root a plus 1. So that squared is just a plus 1. How nice. Minus. Technically, this is in parentheses, but they don't matter in this particular instance. Minus the second thing squared. Well, that's 4. And oh my goodness, guess what a plus 1 minus 4 is? So good. So this is still down the bottom. Don't forget that's sitting there. But a plus 1 minus 4 is just a minus 3. It's going to cancel with this a minus 3. And I'm left with just 1 over that denominator. And you put a 3 in there. And you get 1/4. Sound good? Excellent. You've been a great class.